student in this topic, physical quantities and measurement. We will study about the physical quantities, that is density, and how to measure the density of liquids, density of solids, and how to measure the density of irregular solids. Students, in our previous chapter of physics, we have gone through the chapter that is matter. In that we have studied about solids, liquids and gases. We have studied different examples of solids, liquids and gases, and in this chapter we are going to understand the density of that solid which we have studied in the previous chapter. We are going to study about the density of liquids. Now in density we will study the density of solid which is a regular and irregular form, and we'll study about the density of liquids, how to measure the density of liquid with the help of some measuring cylinders. Now the first part is the density. Now we'll first understand what is density. We know that density is something which is having mass and having the volume. Now how we'll understand the mass and volume? In the book it is given that each body has a certain mass and definite volume. The volume occupied by the body increases if its mass increases. The volume occupied by the body increases if its mass increases. Similarly, the mass of the body increases on increasing its volume. Further, it is found that equal mass of different substances have different volume. Now student, this is very important, that equal masses of different substances having different volumes. Now it has been seen that masses are equal but they are having different volume. Now for example, they have taken as the volume of cotton is much larger than the volume of an equal mass of liquid. Now cotton, you can see it is fluffy and it takes so much of the space to keep, whereas lead is a solid part, it takes less space to keep it. So this is because the particles of lead are closely packed while those of cotton are loosely packed. So lead is denser than cotton, although the lead is denser than cotton, but cotton is taking more of the space than lead because the molecules of cotton are loosely packed and molecules of lead is tightly packed. The next example they have taken as equal volumes of different substances have different volumes. That is, the volume is equal, but although their volumes are equal, they have different masses. Now example they have taken, the mass of iron is much more than the mass of equal volume of wood. Now the reason is because the iron are more closely packed than those of wood, so iron is denser than wood. Thus to explain equal volumes of different substances and have different masses, or equal masses of different substances have different volumes, we are going to understand about the density. Now from this we have just generated that there is some other thing which is called density. Now density is something which is having mass and the volume. So density is represented by the letter D. You can write D or you can write small d. So it is represented as mass upon volume, and the SI unit of density is, the unit of mass is kg and the unit of volume is meter cube. So it is kg per meter cube, and Cgs unit of density is gram per centimeter cube. Now the relationship between SI and Cgs unit of density is, now we know that the SI unit of density is kg meter cube, kg per meter cube, or kg meter minus 3 to the power minus 3. It can be written like this: 1 kg is equals to 1000 grams and 1 meter cube is equals to 100 centimeter. This will be which will be equal to 1 upon 1000 gram centimeter cube. So the relationship between 1 kg meter minus 3 will be equal to 10 to the power minus 3 gram centimeter cube inverse. Now coming to the topic, we have studied about density. Now we will know the density of solids. Now we know some solids which are regular solids like rectangle, triangle, cube, cuboid, etc. So the volume of cube, we have already studied this in maths also. Volume of cube will be equal to L cube, because all the sides are equal, so it will be L cube, or one side cube or edge cube. Volume of cuboid will be, in a cuboid we have same length and same breadth, that is length is equal to, length and breadth are having different, length and breadth are in different measurement. So in volume of cuboid will be L into B into H. In the same way, volume of cylinder will be pi r square H. So these are the some examples of the measurement of some solid, regular solid objects. These are regular solid objects, and with this we can also find the density of these objects as per the requirement. And the density of liquids, can be measured with the help of some measuring objects, and the measuring object is measuring cylinder, measuring beaker, and Eureka can. Measuring cylinder, measuring cylinder is like this. You can see these measuring cylinders in physics lab. This is available in physics lab. These measuring cylinders have markings given, and accordingly we just fill the measuring cylinder according to the need. These both are measuring cylinder. This is a small measuring cylinder and this one is a big measuring cylinder. The marking starts from 0 and it goes till 100. The next measuring cylinder, you can see these measuring cylinders are used by the milkman. These cans, it is of 500 ml and it is of 1 liter and 500 milliliter, and there are different measuring beakers used by milkman, and it is also used in the grocery shops where the mustard oil is given. There also you can see these measuring cylinders, measuring beakers. It is made up of glass or plastic, or it is also made up of aluminium. The next one is the Eureka Can. A Eureka Can is a glass or polythene or metal beaker with a side opening near its mouth, which is known as a spout. Thus, the beaker can contain a volume of a liquid up to the spout, and this any excess of liquid overflows through the spout. It is shown in the figure. You can see this is called the Eureka Can. So any extra liquid is filled in this Eureka Can. This will flow out of the spout. It is like of a funnel shape. You can see the funnel shape over here. So this way we measure the density of the liquids. Now the next part is the density of irregular solids. How to measure the density of irregular solids like stone, etc. Now in this activity they have shown how to find the density of irregular solid. Now student, what they have done in this activity is they have taken two measuring cylinders, and two measuring cylinders. The first measuring cylinder is filled with water till 70 ml, and the next measuring cylinder they have filled the water till 70 ml, and then they have just put a irregular solid in that measuring cylinder. Suppose they have taken a stone or small pebble, and they have tied this stone with a thread and put this stone inside the water, and you can see the level of water rises till 80. It has risen up till 80. Previously it was 70, but because of this stone has also taken the space in the water, and that is why the level of water has increased. Now you can see there are now we got the two volumes. The volume was 70, now the volume is 80. So there are difference in the volume. So for that we will take out the difference in the volume, and then we will solve the density. Suppose the mass of the solid is given as 78. So density is mass upon volume. So mass is 78 and volume is the difference of the two volumes, that is V2 minus V1. V2 is the final volume which we got after putting the pebble or stone inside the water, and V1 is the previous or initial volume of the liquid, that is water. So we will subtract that. So previous it was 80, you can see previous it was 70 and now it is 80. So 80 minus 70 will be 10. So the volume is 10. So density, we can now easily find the density. Density mass is given as 78. Volume, we got the final volume as 10 after subtracting final minus initial, and then the density will be mass upon volume, that is 78 upon 10 which will be equal to 7.8 gram centimeter cube. So this is the way we find the density of irregular solids. Now they have taken the help of Eureka Can. How they have solved this? They have just put the water in the Eureka Can till the spout. Now after that they have put the pebble or stone inside the Eureka Can, and you can see the water has risen up till the spout, and the extra water comes out of the spout and it is stored in the measuring cylinder, and that measuring cylinder is having marking which shows the volume of the which shows the extra water inside this measuring cylinder and shows the mass of this pebble which is inside the water, because a stone is also taking space in the water, and that much space which a stone is taking, that amount of water will come out. This is also called Archimedes Principle, and this water which is coming out is equal to the mass of the stone. So again they took out the density of the solid, which is mass upon volume. Mass is 310 and volume is 40, so they got the density. So this way we have found it out, the density of this way we understood about the density and the density of solid and liquid of a regular object and density of irregular solids like stones or pebbles. In the next class we will go through the density bottle. How is density bottle used for measuring the volume of liquid, and how we find out the density of the liquid with the help of density bottle.